right, today's video is going to be on complex numbers. So we talked a little bit about complex numbers in 1.4 when we were dealing with quadratic equations, meaning that when we had a square root of a negative number, it gave us an I, or imaginary unit. So starting from the top, the square root of negative 1 is I, the imaginary unit, where I squared equals to negative 1. So with that in mind, we're going to talk about complex numbers. Complex numbers are obtained from real and imaginary numbers combined together. The standard form of a complex number is A plus BI, where A and B are real numbers and I is the imaginary. So if B doesn't equal to 0 in the standard form, then the number is considered to be a pure imaginary. All right? So what we are really going to focus on in this chapter is going to be operations of complex numbers. So operations of complex numbers are just like combining like terms. So here we have 4 plus 7i plus 1 minus 6i. So what we need to do here is combine our like terms. So this will be 4 plus 1 and 7i minus 6i. Well, 4 plus 1 gives me 5, and 7i minus 6i will give me a plus 1i. Or you don't have to necessarily say 1i, you can just say 5 plus I, okay? Now, next part is subtracting. The number one thing most people forget is to distribute your minus sign to everything behind that parentheses. So here we would do plus 2 minus 3i, and then bring down this 3i in the front. Then we distribute this minus sign to everything. So this will give me a minus 2 and a minus 5i. So just like combining your like terms, I would do 3i minus 3i minus 5i, and then I would do 2 minus 2. So when I do all of that, my 3i's cancel out here, and actually my 2's cancel out here, so I'm just left with a negative 5i. So this would be considered to be a pure imaginary unit, okay? So now, multiplication, just the same way that we've done before, we FOIL if we have two binomials, okay? So 2 times 4 will give me 8. Then 2 times 3i will give me a plus 6i. Then I times 4 will give me a minus 4i. And then negative I times 3i should give me a minus 3i squared. So now we combine our like terms, which will be 8 plus 2i minus 3i squared. Well, if we go back to the beginning, remember I said I squared equals to negative 1. So you replace I squared with negative 1 because we always want it to be in standard form. So this will be 8 plus 2i minus 3 times negative 1. Two negatives make that positive, so here we would have 8 plus 2i plus 3. Well, the 8 and the 3 can be combined together, so my answer would be 11 plus 2i. Okay, so remember, anytime you see the I squared, you need to replace it with the negative 1. Now, 3 plus 2i, all of it squared, is a little bit different, right? That means we need to expand this into two binomials. So 3 plus 2i times 3 plus 2i, right? And now we get to FOIL. Well, 3 times 3 will give me 9. 3 times 2i will give me a 6i. 2i times 3 will give me another 6i. And 2i times 2i will give me a 4i squared. So again, combine our like terms. 9 plus 12i plus 4 times, well, remember, anywhere you have an I squared, you need to replace it with a negative 1. So that would be times negative 1. So 9 plus 12i minus 4. Well, you can combine together the 9 and the 4, and that'll give me a 5 plus 12i. Okay? Now, if we move a little further, in the previous chapters, we've talked about conjugates. Conjugates were the plus and the minus, right, having the same numbers, or just kind of like a difference of squares. But the difference in complex numbers with their conjugates is now a squared plus b squared. So obviously, what is the conjugate of 2 minus 4i? The conjugate of that would be 2 plus 4i. And just like I'm going to follow along with the rules, this is really saying my a is 2 and my b is 4. So this will give me 2 squared plus 4 squared. Essentially, we don't worry about the I, because when we FOILed it out, the I squared became a negative, and then that's how our B squared became positive. Okay, so 2 squared will give me 4, and 4 squared will give me 16, and 4 plus 16 will give me 20. So now I found my answer. The reason why we're doing the conjugate is because we have to kind of, same as rationalizing the denominator, we're going to do the same thing when it applies to complex numbers. So that'll be 4 plus 2i, which is the conjugate of that, right? And then at the bottom, right, this would obviously be 4 squared minus, not minus, plus 2 squared, right? And at the top, we have to do what we were doing before. We have to FOIL. So this will be 2 times 4, which will give me 8. 2 times 2i, which will give me 4i. 3i times 4i, 3i times 4 will give me a plus 12i. And 3i times 2i will give me a plus 6i squared. So at the bottom, I can work that simply. That'll be 16 plus 4 again, right? And then here, this will be 8 plus 16i plus 6 times negative 1. Well, 6 times negative 1 is going to give me a negative 6. So this is really saying 8 plus 16i, minus 6, right? So if I do that, 8 minus 6 will give me 2. So the top part would be 2 plus 16i over 20, right? Because I add the 16 plus the 4. So now, am I done? No. Very similar to rationalize the denominator, I can kind of simplify my fraction. 2, 20, and 16 all have somebody in common called a 2. So 2 goes into itself 1 time, 2 goes into 16 8 times, and 2 goes into 20 10 times. So that would be my final answer. Okay. Now the last part about today is considered to be the principles of square roots, right? So principles of square roots, as we know, if I took the square root of something negative, right, it would end up being I square root of A. And what do you mean by that, Ms. Parker? So let's say I had the square root of negative 3, right? Well, then this would give me I square root of 3, right? Or very similarly, if I had the square root of negative 25, that would give me 5i, because again, the square root of 25 is 5, and then square root of that negative 1 is I. So we have a few operations when it comes to principles of square roots. So for instance, if we had the square root of negative 3 times the square root of negative 12, right? Well, first things first, I would get rid of these negative parts. So this would be I square root of 3 times I square root of 12, right? So now you multiply the two imaginary parts, which will give me I times I, which is I squared. And then multiply this 3 times 12, which will give me what? 36. Well, square root of 36 is 6, and I squared would be a times a negative 1. So 6 times negative 1 will give me a negative 6. So just as we have done with multiplication, you can also do something with the division. So in the division part, let's say I had the square root of negative 45 over the square root of negative 9, right? So with that being said, I can do what? I can put it all underneath one thing, or I can actually eliminate these i's. So that's I square root of 45 over I square root of 9, right? So what happens with my i's? They cancel out. Now, here's the deal. To simplify this just a little bit more, technically this is really saying 45 over 9. Can I divide 45 into 9 or 9 into 45? Surely I can. That would give me 5. So my answer would just be square root of 5. So you have your worksheet. Work on that, and we'll go from there on Monday. Thank you.